Well, I'm glad to be the last one because the last one has the right to do the closure and see all the pictures. So I'm Aviad from Mellanox, and I didn't bring my leather jacket yet. I'm going to talk today about, you know what? I'll tell you what I'm not going to talk about today. I'm not going, you won't see me pitching any Mellanox chips here. I'm not going to throw in any part numbers of Mellanox, and I'm not talking about any proprietary technology that I'm calling open. I'm going to talk about what do I think is the next thing to do. A little bit in 2 minutes about history. We started with this aggregation between platform and software. We called it ONI. We is the community, is this room, is these people that were driving it, and I'm kind of a gray hair. I think I was there from the first session. So we got a disaggregation between the software and the hardware. We were promoting Open Network Linux and having the ability to control the hardware no matter which is the vendor. Then we went on and moved to opening the interface between the protocols and the hardware, which we call software SI, Switch Abstraction Interface. And now everybody is in the room. We have a full day, full board session about SONiC. But basically, yeah, we have a switch which is open and that is doing a BGP machine, right? So we have an open BGP machine. I'm not underestimating. This is huge. I wrote a blog about how SONiC is making Open Ethernet a dream come true. But what is the next? What is the future? And I want to talk about the future. In my opinion, this community should be using SONiC as a platform to drive the next thing. The next thing is data. Okay? We, as a world, need data. And that data, and the important data, in my opinion, is around telemetry, is around how do I debug my network as efficient as possible. Now think about it. SONiC is a unified operating system that runs in many data centers in the world. Okay? And if we can generate data from those data centers and understand where something went wrong, where did my FRR fail, where did I got a black hole route, then we can take this piece of information contributed by any data center that is running SONiC, and those are tens and hundreds of thousands of ports. If we can utilize that data and take it to understand where we're going, then we can reach the holy grail, which is autonomous networks or self-healing networks. So let's talk about what is telemetry. Telemetry, and again, this is not Mellanox or any of our hardware devices. This is in general. So if you look at what are the data points that drive telemetry, so the legacy stuff, you have counters in the switches, you have statistical sampling, sflow, netflow, IPFix, whatever. And then Mellanox and others are talking about event-driven telemetry. When something goes wrong in the network, you want to know it immediately and stream it outside and be able to expose it. And again, Barefoot and Broadcom were talking about Flowdriven. Of course, we have Flowdriven as well. So this is a matter of, okay, now we have all those 4 points of the data itself. All of them are very much important. So in a nutshell, why event-driven? I think event-driven is the last one that people are talking about now. I think event-driven is a key part to make telemetry efficient. And you can look at it comparing to a dashboard of a very 747 Boeing. You have tons of needles there. But the question is, should we be watching those needles to understand that something is wrong? Event-driven telemetry just tells you, check your oil level. And once you check your oil level, you can fix the problem and provide remediation. This is the key driver for making telemetry efficient, okay? We don't want too many dashboards. We want to have the indication, the right indication when something goes wrong in the network. And this is kind of a comparison between the different technologies. If we look at statistical sampling, compares to event-driven and flow-driven, flow-driven is like instead of going to the catfight between different lanes of in-band telemetry or IFA or whatever, it's just basically I'm detecting the flow end-to-end. So you can see that there are many categories from physical layer to microburst to end-to-end application, and each of those mechanisms provides something different, okay? Some of them can cover a network utilization, and some cannot because simply it doesn't have the application. But this kind of give you a plot that we need all of them. We cannot live without any of them. And if I want to do the analogy, how do I look at the flow of debugging your network? So basically, at the beginning, you need to have that raw data. And if how do we start to debug our program when we are running a CPU? We top it, right? We just issue the command top, and now we get all the processes that are running and all the counters that are happening, and we can get a high-level view. This is totally equivalent to reading your counters or getting your sflow data, okay? So you get a good picture of the network, but is it sufficient to debug? Well, sometimes we used to be doing trace routes, etc., or looking at our sflow data, but then it took us weeks sometimes to nail down a problem. So then you have event-driven telemetry. And event-driven telemetry, you can look at it as if it's your log files, right? If something goes wrong and your application was crashed, you look at your log files and immediately you find your problem. Event-driven telemetry is exactly about that. So you get your cable was flapping, boom, you get that information immediately. You have a black hole route configured, boom, you have this information. Actually, you forgot a phantom ACL somewhere in your network because you copied your configuration. Your network should identify, I'm dropping packets in a high rate due to that ACL. That's event-driven telemetry. And then once you have the identification, now you can go and GDB your network by doing flow-based telemetry. Okay? So all of them are a flow. And this is, in my opinion, the next generation, and we can do that together as a community with SONiC. Look at this flow. So at the beginning, this is something that we find, or you might run into this problem as well. I call it top of the hour congestion. Sometimes you have a scheduler that is doing a workload, and those workloads are synchronized. It's a parallel computing workload, and now many of the CPUs are trying to do the same thing or trying to work their piece of load at exactly the same time. And they will create a microburst, and that microburst will create an event, okay, because a packet will be dropped in an egress queue. And now that the packet is dropped, it is logged somewhere in a database, and then, again, you will have another, so now you can issue a flow end-to-end to try to see whether is it broken in a path. You can apply remediation based on or verifying that there was some kind of increased latency, and call your orchestration to do a migration and close the locality of your VM or container placement. And the nice part is that now you can do an equivalence to inference in a convolutional neural network. When you get your sflow statistical sampling indication that something is happening, it's not even dropping the packets yet. You can predict that the network is going to drop the packet, and based on that database. And this is exactly where I think we should be going. We should not talk about bits and bytes on a specific hardware. We should talk as a community, how can we leverage the fact that SONiC is deployed in so many data centers to create something like this, to seek or to apply AI technologies on database driven by those data centers in order to be able to do prediction and self-healing networks. Okay? So this is the call for action, guys. I gave it a name. The name is not important. I needed to enter a name. The first thing that popped out of my head was Open Fabric Monitor, so I Googled it to verify that it's not some slang in some language, and I found out that OFM can be one feature missing. So let's make it our fabric monitoring and non one feature missing. And I think that basically this means if we can talk, we need to talk about, of course, we need to have unified interfaces, and a few interfaces were proposed here before in the previous talks. So I agree that we need to have a standard format. It is not that matter what would be the standard format. I'm sure that as a community, if we were able to drive a unified format for configuring our ASICs, We can define a unified JSON format to stream out the telemetry data. But the important stuff is collecting the data and presenting the data. And I think that my suggestion here to this community is to come up with a framework for telemetry. We need the first piece would be defining that interface out. The second piece would be to define a framework, ELK or TIC or whatever other frameworks that we can use from open source to create a database. For example, InfluxDB is a good example, or Logstash. We can take that information, log it into a database, collect the database, and then we can run tools to analyze what went wrong in the network, okay? And then we can share as a community, look, if you're using SONiC, this version, and your network is deploying BGP at this scale and that topology, if you run into this problem, we already faced that. And that's big. That's really providing a true added value of using an open source and community sharing and network operating system. So the call for action, and this is my last slide. The call for action is, first of all, let's define that API. We can start from, there was a proposal here to use Broadview. In my opinion, the success or the reason why SONiC was so successful is no vendor was the maintainer. Okay, in order to make an open source successful, you need a third party as a maintainer that controls and can verify that you're not blocked by your competition. Okay, so once we define that, if Broadcom will contribute Broadview as part of the community and the community can maintain it, by all means, I don't mind. And then once we define the interface, and by the way, not the transport, we need to define how to stream it, then we need to think about building together, creating that database, and streaming the data, do analysis on the data, and then create a database with remediation if you run into issue with SONiC, how to display, how to have a unified tool showing event and flow statistics and flow-based telemetry, and then use the data learned here in order to help the community as a whole. Thank you.